angles, angles, angles. So students are notorious for writing this out like this. This is angels, like with halos and wings, or the baseball team in Anaheim. We're talking about angles, and we are going to talk about some very specific pairs of angles that you need to know often, all the time, for the rest of math. And so this video is going to be kind of long because there's a lot to it. Your notes are going to be long because there's going to be a lot of vocabulary to write down. So do it in chunks. Take your time. This vocabulary is humongous. You will be using it over and over and over and over. And I'm going to say, hey, remember when we talked about vertical angles? And you're going to have to say, yes, I do. So, very beginning point here, array. This vocab you should already have written down. Array has one endpoint and goes in one direction forever. An angle is two rays that have the same endpoint, and we call that endpoint the vertex. The vertex, that's a huge vocabulary word. It's the endpoint that the two rays have in common that make an angle. Some people like to say the vertex is the angle. Okay, so write this down. You probably know these. You learned them somewhere along the way in, like, I don't know, 3rd grade or something. Whether or not you write these down is up to you. A right angle is 90 degrees and usually has a little box in there to tell us that it's 90 degrees. An acute angle is less than 90. An obtuse angle is bigger than 90. Notice it's real big, right? And a straight angle, which might be the only one you haven't learned before, is basically a straight line. I'm going to redraw it because somehow it messed up. I don't know. And it's 180 degrees. The measure of a straight angle is 180 degrees. Now, we name angles. We can name them actually 3 different ways, really 4 different ways. So we can name it by its vertex, which would be B. So we can name it just angle B. If it's the only angle there. If you had 2 angles at B, so we have this angle and this angle, right? Then you can't name it B because we don't know which angle we were talking about, okay? So in that case, we have other ways to name our angles, which would be that we can name them with the 3 letters. So a point and a point outside from the vertex. And the vertex is always in the middle. So we can go A, B, C is an angle. The vertex is always in the middle. We could also call this angle CBA. That's technically the 4th way, is you can put the letters either direction, CBA or ABC. But notice B has to be in the middle. The vertex is always in the middle. And then sometimes they give us a name in the angle. So sometimes there's a little 1 inside the angle that says we could name that by angle 1. That doesn't happen a lot when we get to the point of working with triangles and things, angles like that. More often what you see in there would be the degrees, 35 degrees, but we can't call it angle 35 degrees. Okay, that's not a thing. So this one sometimes happens, and then the using the 3 letters is kind of the fail safe. If you have that no matter what is going on, as long as you have the 3 letters, you should be able to use all of those. So congruent angles, you've probably learned somewhere along the way, we've already talked about this, I think, that congruent means equal or the same. And we use this symbol, congruent, squiggly over equals, to mean congruent. Okay? And we would talk about that an angle has a measurement or a degree of, say, 75 degrees, and we would write it like this. Do not call this the little m, okay? You would read this out loud as the measurement of angle ABC, or the measure of angle ABC equals 75 degrees. I'm going kind of fast because there's a lot in these notes. Pause what you need to so you can write stuff down, okay? Adjacent angles are when we have more than one angle and they have a common vertex and a common side. Okay, so it's two angles, can be more, usually we talk about two, angles that are right next to each other. They have a common side. So this side makes up this angle and this angle. They have a common side. Again, you need to be pausing and writing this stuff down. Okay, complementary angles. This is a definition that you absolutely need to write down and memorize. Complementary angles add up to be 90 degrees. So you could have a 40-degree angle and a 60-degree angle, not drawn to scale, of course. Wait, that adds up to 100, huh? Let's try having a 50-degree angle. 40 and 50 is 90, so that would be complementary angles. We're going to do lots of examples with this, so just get through write down the vocab, and then write down the examples when we get there. Supplementary angles add up to 180. So you could have 95 and you could have 85. That actually adds up to 180. Yay. Okay? Supplementary angles add up to 180. I cannot stress to you enough that this is a definition that you absolutely have to memorize. Absolutely have to memorize. You will use this over and over and over. So what does this mean for us in our practice time? Well, you'll be given a group of angles, right? And you need to find the missing angle, which in this case is B. So we could actually call that angle B, but we really would never need to do that. And so notice we have right triangle, right? I mean a right angle, right? So that means we have a right angle here, which means that these two angles put together are a right angle, okay? Which means that 58 plus B equals 90. These two angles are complementary. And so we can do the math and get that B equals 32. I think I did that math right. 90 minus 58. Yes, 32. And you're done, because that's all you want to know. Missing angle, B, 32. Okay. These are complementary because they add up to be 90. Now, here we have a straight angle, a straight line, which means that together this whole thing is 180, or supplementary. So we can say that 109 plus B equals 180, and do that math. Oops. And 180 minus 109, I'm not trusting my brain right now, is 71. So B equals 71. Again, supplementary because they add up to 180. We know that because they're on a straight line. Now, this pair, like this, actually has a special name. They are a linear pair. Okay? We'll come back to that. I want to do this example. So again, we have a right angle box, so we know that these two add up to be 90. They are complementary. So we would do 5x plus 3 plus 22 equals 90. This is a lot like angle addition, because we do the part plus the part, but in this way we know that the whole is 90. So 5x, whoops. So let's combine our like terms. I was just going to do it without talking through it, sorry. So 5x plus 25 equals 90. Subtract the 25. 5x equals, again, not trusting my brain today, so whoops. Apparently I shouldn't trust my fingers either because I keep typing it wrong. 65, divide everything by 5, and x equals, that's 15, right? 13. I'm okay. See, this is why I don't trust my brain. 13. And all we want to do is solve for x. Okay, there might be a time when it asks you to solve for the angle, and so you would have to put that back in there to figure out what that angle is. You can also do that to check your work. You could put 13 in there, or really 13 in there, and check your work and see if you really get 90. All right, so linear pair. I'm going to say this again. You absolutely have to be able to identify a linear pair on a site, at least until you graduate from high school. It is huge. We use it. It comes in handy as we do all of our geometry stuff the rest of this semester and then into math too. Okay? Absolutely learn it, memorize it, do not forget it. A linear pair is when you have opposite rays or a straight line, right? And one ray coming off of it like this, okay? If the official term is a pair of adjacent angles, okay, who are basically on a straight line, okay? And a linear pair is always supplementary. Again, you absolutely have to be writing these down. If these definitions are not in your notes, you will not get full credit. So a linear pair is supplementary, meaning this angle and this angle add up to be 180. Okay? You will see linear pairs all over the place. Sometimes they're nice and pretty and look like this. Sometimes they're upside down and look like that. Sometimes they're just two lines that intersect, and you have to identify that 1 and 2 are a linear pair, or 2 and 3 are a linear pair, or 3 and 4, or 1 and 4. Okay? They're on a straight line with one ray coming off, no matter what that really looks like in the picture. Okay. So here we've got a straight line, one ray separating this angle from this angle, so we have a linear pair. We know that they are supplementary, and so therefore we can set up an equation, 4x plus 1, this angle, plus this angle, x plus 24, is equal 1 to 180. And then we solve for x, because that's what we're looking for, solve for x. So we've got two constants, we've got two x terms, so let's combine those. So 5x plus 25 equals 180. Subtract 25. Isn't this the same math we just did, basically? 5x equals, maybe not, 180 minus 25. Oh, no, I guess not. 155. Divide by 5. And x equals 31. And that's all we have to do. We could put that back in and find either one of those, and you could do that to check your work if you wanted to. Let me remind you, every example needs to be in your notes as well. Okay. Last vocab for the day, vertical angles. Vertical angles are also everywhere, just like linear pairs are. Okay. Vertical angles are opposite angles. So anytime you have an intersection of lines, and you have angles that are opposite of each other, see how 1 and 2 are kind of mirrors of each other? Those are called vertical angles. Huge, huge, huge vocabulary that if you know that they're vertical angles and you know that they're equal, it helps you when we start looking at triangles and quadrilaterals and stuff. Okay? So make sure that you have written down this and that you have written down this. Okay? They are equal. Vertical angles are always equal. So, vertical angles would be 1 and 3 and 2 and 4. They're opposite of each other. Our linear pairs would be 1 and 2, 2 and 3, 3 and 4, 4 and 1. Huge vocabulary. I cannot stress this enough. Huge vocabulary. Okay? And so once we know about vertical angles and linear pairs, we can find out all of those angles. Okay? So And I'm just going to ignore the numbers and just kind of go. So here we know this is 48, right? Well, opposite of that is also going to be 48. They're equal. They're vertical angles. Okay? We know that these two are going to be equal, but we don't know what either one of them is yet. But we can figure it out because we know that 3 and 4, or 2 and 3, or those two, however you want to look at it, we know that those are linear pairs. So if these two are a linear pair, because really it looks like this, right? And if this one is 48 degrees, then we can do 180 minus 48 in the calculator, of course, and we get that this one is 132. And if this one is 132, then this one is 132 because, again, they are vertical angles and equal. Please, please, please go back to this video and make sure that you have written everything down and that you are starting to memorize it, and ask questions in Zoom when you have it.